Do you want to start PLC programming but don't know where to start? Then this video is for you. In this video we're gonna talk about what is a PLC and what it can do. Then we'll create a new project from scratch step by step. I'll try to break it down as simple as possible. After that we will add a new device into our programming environment, and then we will talk about what is the main OB and scan cycle. If OB1 feels like a mystery box in TIA Portal, then this video will make it finally click. During the video, there will be some tips and tricks that I use in the real-world projects, so make sure you will note them down. You will definitely need them. So let's get started. What is a PLC? A PLC stands for Programmable Logic Controller. It's a small computer that tells machines what to do. It watches the inputs, which are the buttons, the sensors, and then turns the outputs on and off, like motors, lights, alarms, or clamps. You can think of it like the PLC is the brain, the inputs are its eyes and ears, and the outputs are its hands and voice. For example, think of an elevator. You press the button, the doors close, and it goes up and down. The PLC is the brain making that happen. So let's jump into our programming environment. We'll start with opening the software. So here the TIA portal is opened. Everything is blank because we don't have any projects. Then we go and create a new project by clicking in this button here on the project tree, create new project. And then here you give the project name, the path, and then press create. And then this window pops up. We have two views. We have project view. If you press here, this is our project view. And here we have portal view, the other window. And you can add devices from the project view by clicking here, add new device, or better is when you open the project blank like this, you go configure a device and then add a new device. Here we have the controllers, HMI, PC systems, but for now, for this video, we will just add a controller. Here you have different families of controllers, but for today's video, I would like to go with the 1500s, which is the most powerful PLCs. And you open CPU, and here you have different categories, and you see the yellow one. Here you have the blue one, the yellow one. The yellow ones are for the safety. So if you have some safety in your station, you have to use these ones. But for today's video, we will just go with any of them. Just pressing the first one, you have here different article numbers. They're different, right? If you press on them, you will see the description. They have different memories and different for different applications, and they also have different versions. But for now, I'll just press the first one, add. And our first hardware is already added into our project programming environment. And here we have three views: topology view, network view, device view. Mostly the topology view you will use if you have many devices and you want to see how they are connected, right? Like the physically, which device is connected to which device port. And the network view, you will see all of your devices, and in the device view, you see more detailed information of the selected device. Here you can choose between devices if you have more. So for now, we have only the CPU. And the hardware catalog, there are so many different functions, right? Like you can see here on the right corner, on the left corner. Don't worry about them for now. We will go through all of them step by step. But for today, we will just learn the most basic part, how to add a device, how to start with TIA Portal, right? So here you see you have the CPU. You have different hardwares for this CPU. For example, let's say we add a digital input. You just open it, drag and drop here. And let's also add a digital output. Here we added 16 bits, right? 16 digital inputs. Let's also add 16 outputs. And you can also add a power supply, for example. A tip would be when you press on the hardware, you will see here the device picture and you will see some descriptions. And if you want to know more info about this device, what you can do is right click on it, go to product support information, or you can also go to manuals. It will take you to Siemens website and you will see there some data sheets and more technical information about this device. Yeah, for example, we can add this one here as well for now. So we added digital input and digital output. And here, if you open this small device data, here, you see more information about your device. And here, for example, if you press on this input, it will highlight the hardware here. If you press on the output, you can see it's highlighting this hardware. And also another tip would be, if you zoom in, I hope you can see it. Here you have I0.0 until I0.7 and then I1.0 to I1.7. What that is, here you see we have 8 bits. So this 8 bits is the first byte. We said we have 16 inputs, which are digital inputs, and they are 1 bit. So 1 byte is 8 bits. That's why we have 16 of them, and it is 2 bytes. And the first tip is here. If you have more devices in your project, and here you see the addresses, the start addresses. None of the 2 devices can have exactly the same address. If you have, for example, some other device, they cannot have 0 and 1, right? Otherwise, it would give you some error. So you can add here, for example, you can change the addresses. If you press 5, for example, let's say, and enter, it will take 2 bytes, 5 and 6, because it is 2 bytes. And here you can see it's changed from 0 to 5 and 6. Same goes for the output. Here you see this one is for the inputs and this one is for the outputs. This card has only outputs, that's why it does not have here. If it had inputs as well, then you will see here. You can change, for example, to 8 and you see 8 and 9. Just to show something, if you choose, for example, digital input and output, let's take to this card, and then you press on this, you see it has and inputs and outputs, right? For example, if you make 10, and here for the outputs as well 10, then you can see it here. Unfortunately, we cannot see it because a bit small, but yes, this is the idea. For now, let's just delete it, we don't need it. But this one was all for the hardware, and for the hardware, you can change the name. Here, for example, Project 1, you change the name of your PLC, or you can change it here by double-clicking. And every time when you add some hardware, the best way is for compilation is you can compile just by pressing here and here. It will compile hardware and software. Or how I always do it, if I add some hardware, if I make any changes, right-click, compile, and first you have to do the hardware rebuild all. Then you see you have 0 errors. It's compiled error-free. Then if you have some software changes as well, then you can compile software rebuild all. Right? This is how I find it's very important, because if you make some changes in your hardware and then if you press here, it will try to compile hardware and software at the same time, and sometimes you might have some errors. Now let's go to main OB. Here, when you add that device, under the program blocks, it automatically generates you main OB1. It's always there. It's the main organizational block. And this OB1 runs from top to bottom, from left to right, again and again every scan. Right? So the inputs are read with every scan, and the logic is executed, and the outputs are written. This is how the scan cycle works. Here I have drawn a small sketch to understand better. So the scan starts, their inputs are read. It starts from network 1, network 2, it goes down, writes the outputs, and the next scan starts. We will demonstrate a small example to understand it better. So here let's add a small logic. We say start. We add a new network here. Don't worry for now about all of these options. We'll go through them in the next videos. For now, we just focus in the first steps. And here, let's add here normally open contact and output. And here, let's say we take M0.0. This is an internal memory of the PLC. Take one, and for the output, let's take M1.0. And here, we don't need this one. And we take this one. To drag and drop, press and hold Control as well. Otherwise, you will just cut and copy it here. And here, let's say Q0.0. So what we did is here, for example, this one is a button. You press a button. The state of this one, we write to the tag 2. And then the tag 2, we read here and write a lamp. For example, let's say it's a lamp. Basically, you press a button, a lamp turns on. But this one, the result of this logic, we are saving it into this memory to read it here, and then we write the output. This logic we are demonstrating for the scan cycle purpose. You will understand now. Let me just compile this one. You can compile software because we did some changes in the software, error-free. And now we start the simulation. There's two ways of starting the simulation. You press here, you press Start Simulation, or you go to Online and Simulation here, Start. Just start the simulation. Okay, okay. The PLC sim will start running. So now we choose here PLC sim. It finds the IP address, load, connect. Load. Here we will choose start module for the start modules. And our program, our logic is already downloaded to PLC sim. You can here go online. And so here we will see everything is green, so everything is good. And inside this main OB, you can also go here and monitor so that you will see. So for excuse me. So to explain the scan cycle, let's say we said it will go from network 1 top to bottom. First it reads the state of tag 1, writes it here, then it goes to the next network, reads this one, writes here. So what will happen if we turn this one on? We turn on this tag 1, it writes in the tag 2, reads here and writes here. This is the scan, the first scan, let's say. And then if we change the order of the networks, now let's see what is gonna happen. Here we change it, you see that there is some changes, so everything turns to orange. It means the logic is not inside the PLC anymore, so you have to go and download again after every changes. Now everything is green, everything is good. So now we change the order of the networks, and in the first scan, we were turning on the tag 1, right? So it will read tag 2. It's off, even if we turn on the tag 1 in the first scan, it will be off, right? Because it starts from top to bottom. This one will be off, the light will be off, and then it goes and see, okay, tag 1 is on, then I turn on the tag 2, and in the second scan, then it will turn on the light. Let's go. Unfortunately, we cannot see it by eyes because it's like super fast, 10 to 100 milliseconds, the scan cycle, so we cannot see it. But the idea is that in the first logic, when the start was in the first network, the output turns on in the first scan cycle. But when we change the order, it will turn on in the second scan, because in the first scan, tag 2 will be off. Don't worry if it's too much information for today. We will go into more details in the future videos. We will go slowly. We will slowly progress to more harder examples. We will start with small examples and then we go slowly, so you will understand more. But for now, if you have some questions or doubts, you can write down in the comments below and I'll try to help you out. For now, I will cut the video here. If you found this video helpful, consider subscribing so that you will not miss out in the next videos.